Okay, be sure to have your homework out. And again, remember this can be paused at any time, so if you need time to get caught up, just ask that it be paused. Quietly raise your hand. Questions 1 and 2 from yesterday. Again, this is where they were asking you to graph each equation. So if we identify the slope and the y-intercept, these are in the form y equals mx plus b. So the slope will be the value in front of the x value, and the b is the part that's after the x value, including the sign that's attached to it. So the y-intercept is a -3. The slope is 1/2. The y-intercept is where we start, -3. This is how much my y value is going to change compared to my x value. So it says that I'm going to go up 1 and over 2, and you can see that that pattern continues on this line. Same thing happened over here. Remember that if you see a slope that's an integer, that you can always put that integer over 1 so that you can see how much it's going to change. So if I started at 2, I can see that my y value is going down 3, and it's going over 1, and again, that pattern would continue throughout that line. Number 3 from your homework, it gave you the equation y equals 4x plus 2. The slope of the line is 4, and the y-intercept is 2, so it's going to start at 2, and it's going to go up 4 and over 1, up 4 and over 1. And it says discuss which points on the line do not make sense in this situation, and then plot 3 more points on the line that do make sense. Coordinates that aren't whole numbers wouldn't make sense because you can't have part of the baseball card, which is why they're showing this as being a dotted line. And you see these points here are actually solid. This dotted line means that it can't exist, but you can see that the trend would continue on and on forever. Number 4 is a sample answer. It says, why might someone choose the y-intercept and the slope to graph a line? It's easy to identify the slope and the y-intercept from slope-intercept form. Number 5, they gave me the equation y equals 0.75x plus 0.25. The slope is 0.75, and the y-intercept is 0.25. Remember that 0.75 is also the same as 3/4, in case you wanted to look at it that way, and you see where the graph would be. 6 through 11, I really recommended that you wrote down y equals mx plus b, so it would be 5x minus 1. And they used the points 0, 1, 2, and 3. And you can see that they consistently did that until they got to one that had a fractional part. And if they had a fractional part, I'm going to write this one out. Y equals a -1/2 x plus 4. They used things that were a multiple of my denominator. So obviously if I plugged in 0, it would give me a 4. But if I took a -1/2 times 2 plus 4, the 2's would cancel and leave me a -1 plus 4, and I could see that it would give me 3. Likewise, when they came over here, they used a multiple of 3. Again, this can be paused at any time for you to have the ability to check your answers. Number 13, they gave me the equation y equals 3x plus 50. And again, the 3 would be the slope, and the 50 is where it's going to cross the y-axis. After locating the y-intercept of a coordinate plane, can you move up 3 grid lines and write 1 grid line to find a second point? So long as the vertical axis and the horizontal axis are gridded the same way, you can. You'll notice that there's 2 units to get to 50, 2 units to get to 50. But if the units are not the same, you could not just count that way. You'd have to make sure that you were using the same amount of units. You can't just count grid spaces. Okay. So today's lesson, again, these can be paused at any time. We're just comparing non-proportional and proportional. Remember, to be proportional, when you're looking at a graph, it has to have two qualities. To be proportional, it needs to be a straight line. But it also needs to go through the origin, 0, 0. So the first one would be non-proportional. And it would be non-proportional because it does not go through the origin. The second one would be proportional because it does go through the origin. So when you're looking at a graph, it's very easy to determine whether it's proportional or non-proportional. When you're looking at equations, remember, to be proportional, it has to be able to be represented as y equals kx to be proportional. We can also think of it as y equals mx plus b to be non-proportional, so long as b isn't equal to 0, because then it would be in this format. This is in the form y equals kx. I see that I have two variables and I have a constant, so this is proportional. This looks like y equals mx plus b. My slope is 0.1. My y-intercept would be 2,000. This is non-proportional. This 2 is almost in the form y equals mx plus b. This is y equals b minus mx. My slope is actually negative. It's a negative 3, and my y-intercept would be 450. So this is a non-proportional relationship. And if I come to look at number 8, I notice that there is only one variable. So this is definitely not proportional. In fact, this is not even, well, if it's not proportional, it's definitely non-proportional. In fact, when I went to do this one, this would actually be d equals 3, and so it would be one single point. It wouldn't even be a line. When you're looking at a table, we need to remember, to be proportional, k has to be equal to y over x, and k needs to stay constant. So 30 over 2 is 15. 90 over 8 is 11.25. This would be non-proportional. 1 over 5, or 1/5. If I put that in decimal form, it would be 0.2. 8 divided by 40, which is also 1/5, which is 0.2. 13 over 65, which is also 1/5, or 0.2. So k did stay at a 0.2, so number 10 is proportional. Your assignment today is to do page 381 through 384. Remember that on Monday this is due, and on Monday you will get a review worksheet, and that review worksheet is due on Tuesday, and on Tuesday we'll be going over that, and you'll have a test on Wednesday, and your prognosis test will be Thursday and Friday. Be on your best behavior.